This video is going to have a look at an example of how to resolve a set of simultaneous equations algebraically using the elimination method. So the first step in using the elimination method is going to be to rearrange the equations if required. It'll be required if we don't have a variable with the same coefficient in front of it. So one of our variables need to have the same coefficient. It can either be a positive or a negative number, but it needs to be the same number. If we don't have a variable with the same coefficient, we then need to rearrange or we need to change the equation to be able to ensure that we've got that coefficient. So we might need to multiply each of those terms in the equations on both sides by the same number to be able to change the coefficient in front of one of the variables. So the next step will be to decide if we're going to add or subtract the equations together to be able to combine them. The third step is then to combine the equations together by either adding or subtracting, depending on what we decide in step 2. The next step is to solve the combined equation that we formed in step 3, and then that will give us the value of one of our variables in the original equations. Step 5 will then be to substitute in that known value into one of the original equations to find the value of the second variable. And then once we have the value of both variables, the final step is to write the answer. So that is a summary of the steps required to be able to complete the substitution method. Now we'll go ahead and have a look at an example. So in the example, I want to solve 2x plus 3y is equal to 10 and 3x minus 4y is equal to negative 2 using the elimination method. My first step is going to be to see if I need to rearrange or adjust any of my equations. And in my equations, I've got a 2x and a 3x, a 3y and a 4y. So after looking at that, I can see that none of my variables have the same coefficient. So I'm going to need to be able to adjust my equations to make sure that I've got a variable with the same coefficient. To do that, I'm going to choose my y. So I got 3y and negative 4y. And I want to make sure that I can change those equations so they've got the same coefficient. So to do that, I'm looking for the lowest common multiple of 3 and 4, which is going to be 12. So to adjust my equations, my first equation, I want to multiply all of that by 4, because 3 times 4 is equal to 12. And my second equation, I want to multiply all of my equation by 3, because 4 times 3 is equal to 12. So making those adjustments, my new equations are going to be, so it'll be 8x plus 12y is equal to 40. And it's going to be 9x minus 12y is equal to negative 6. So when making those adjustments, when you're multiplying the equation, you multiply each term on both sides by the same number. So 2x becomes 8x, 3y becomes 12y, and 10 becomes 40 for my first equation because I multiplied it all by 4. In my second equation, when I'm multiplying it all by 3, 3x becomes 9x, negative 4y becomes negative 12y, and negative 2 becomes negative 6. After making those adjustments to my equation, I can see that I have got a positive 12y and a negative 12y. So I now have got a variable with the same coefficient. So I can go ahead and look at combining my equations. When I'm looking at combining my equations, because I've got a plus 12y and a minus 12y, I want to add them together. Remember, the point of combining our equation is to eliminate one of the variables. So if I plus 12y and plus negative 12y together, that is going to eliminate each other out. So for my next step, when I combine my two equations, I start at the left-hand side of the first equation, and that's going to be 8x plus 12y. And then I'm going to combine that with the left-hand side of our second equation, and that's going to be plus, and then in brackets 9x minus 12y, and that's going to be equal to, now do the same thing for the right-hand side, it's going to be 40 plus negative 6. So moving ahead and removing my brackets and simplifying, it's going to be 8x plus 12y, it's going to equal to plus 9x and then plus negative 12y is equal to 40 plus negative 6, which is going to be 34. So to simplify further, I can collect like terms. So my positive 12y and my negative 12y are going to cancel each other out. So I'm going to be left with 8x plus 9x, which is 17x is equal to 34. So we can see that once we've simplified and collected our like terms, one of our variables get eliminated. So now I can go ahead and find a value for x. So 17x, to get x by itself, I need to divide by 17. So both sides are divided by 17. So x is going to equal to 34 divided by 17, which is equal to 2. So after completing that step, I've got a known value for one of my variables. So x is equal to 2. I can go ahead and substitute in that value into one of my original equations. And I'm going to choose 2x plus 3y is equal to 10. So substituting in my x is equal to 2. So 2 times 2 plus 3y is equal to 10. So 4 plus 3y is equal to 10. So to go forward and solve, I need to subtract 4 from both sides. So that leaves me with 3y is equal to 6. And then to be able to solve that, I need to divide both sides by 3. Therefore, y is going to equal to 6 divided by 3, which is equal to 2. That leaves me with knowing my values for both of my variables. X is equal to 2, y is equal to 2. So I can write my final answer, 2 and 2. So the solution for my original two equations is going to be 2 and 2. So that on the Cartesian plane is where those two lines are going to intersect. So that is an example of how I can use the elimination method to be able to solve a set of simultaneous equations.